Hello students, today we'll be doing about time and distance, the very familiar topic that you have gone through in 9th and 10th standard, and going forward in many of the competitive exams this topic plays a vital role. So let's talk about this. So here we have a word problem on time and distance. Let's look into the question, then we'll discuss about it. The question is, a car is traveling at x feet per second. The driver sees a red light ahead, and after 1.5 seconds reaction time, the driver applies the brake. So generally, the person will take some time to react to any instance. So here, the driver took 1.5 seconds to react, and then he applies the brake. So after the brake is applied, the car takes x by 24 seconds to stop, during which time the average speed of the car is x by 2 feet per second. If the car travels 165 feet from the time the driver saw the red light to the time it comes to complete stop, write a quadratic equation to find the value of x. We know that the very fundamental of time and distance traveled by any object is nothing but speed into time. Hope you guys know about this. Let us try to depict a small diagram to represent this situation. Let us take here a car is traveling. Here he saw the red light. Once if he saw the red light, after how many seconds he applied the brakes? After 1.5 seconds reaction time, the driver applies the brake. So from here, he saw the red light here. From here, after 1.5 seconds, in this point, he applied the brakes. During this time, what is speed of the car? It is given as x feet per second. After the brake is applied, so from here, the car takes x by 24 seconds time to come to rest. How much time has taken to come to rest, guys? It has taken x by 24 seconds time, and during this course of action, what is the speed of the car? It is x by 2 feet per second. Now from beginning to ending, so here he applies the brake, here the car comes to rest or stop. During this time, the car traveled a total distance of 165 feet. Let us try to write a quadratic expression for this. What is the distance travel from here to here? Distance is speed into time. So here speed is x, and the time taken is 1.5 seconds. Plus, here speed is x by 2 feet per second, and the time taken is x by 24. This total distance traveled is how many feet? It is 165 feet. Let us try to convert this decimal into fraction. 1.5 can be written as 3 by 2, right? If you do that, this is x into 3 by 2. X into x is x squared. 2 into 24 is 48. This is equal to 165 feet. If we multiply by the LCM for every of the term, let us multiply the whole term by 48. So this expression will come down to, this is 48 times 3x by 2 plus 48 times, we are multiplying every term by 48, right? And this is equal to 165 times 48. Now write in a sequence of the powers. So 48 gets cancelled. This is x square. Now 2 goes 24 times in this. So 24 times 3x would be 72 into x. Now 165 times 48, if you do product, that becomes 7920. And if it comes to left side, this is minus 7920. This is equal to 0. So this is the quadratic expression we have formed by taking this situation. So this is one simple word problem based on time and distance. So going forward, let's take one more example to understand some more concepts of time and distance, right? So in case if they ask you in terms of a multiple choice question, would have simply tick mark the option 4 to be the right answer. So we have one more word problem which will talk about some of the concept of time and distance. So let's read out the question first. So Tim cycled from his house to his friend John's house and then on to his school without stopping. The average speed for the entire journey was given as 26 kilometers per hour. So here they're talking about average speed. So this is the concept that I would like to discuss through this question. The distance from John's house to Tim's school is 0.3 times the distance from Tim's school to John's house. Tim's speed from John's house to Tim's school was twice that of Tim's speed from Tim's house to John's house. It seems to be a tongue twister, but nothing to worry. Once if we analyze the concept of average speed, then we'll draw a diagram to this. Then what was the Tim's average speed from John's house to Tim's school in kilometer per hour? So this is our question. So before we solve this question, let's talk about average speed, right? So average speed can be defined as the total distance traveled by the total time taken for the journey. Again, there are multiple instances in this. What if the body travels equal distances? What if the body travels unequal distances? Whatever the context may be, here let's try to take a simple example to understand the formula of this. Let's take a car is going from A to B. The distance between A and B, take it as x kilometers. During this time, the speed of the car is A kilometers per hour. Then the car is going from B to C, and the distance between them, take it as y kilometers. From B to C, the speed of the car is B kilometers per hour. Then how do you write an expression to get the average speed? Let's try to write down that. As per the definition, average speed is nothing but the total distance traveled in the journey by the total time taken, right? So from A to C, what is the total distance traveled? A to B, x, B to C, y, which puts together the total distance traveled is x plus y by, what is the total time taken, guys? It is time taken from A to B plus time taken from B to C. We know that time is equal to distance by speed. So here the time taken from A to B is equal to distance by speed, x by A plus y by B. So in this way, you can simply find out the average speed for unequal distances traveled. So the same thing you can do for equal distances case as well. But for this question, we need for unequal distances. Now let's try to solve this question, guys. As we discussed, the question seems to be a tongue twister by taking a lot of wording about Tim's school, John's house, Tim's school. You know, there are a lot of wording into it. So let us try to do a small diagram for this. So Tim cycled from his house to his friend John's house. Let us take, this is Tim's house. From here, he is going to his friend's John's house. And then on to his school without stopping. From John's house, he is going towards Tim's school without any stoppages, right? The average speed for the entire journey was 26 kilometers per hour. From beginning to ending, from Tim's house to Tim's school, the average speed would be 26 kilometers per hour. The distance from John's house to Tim's school. So the distance from John's house to Tim's school, this distance is what? This distance is 0.3 times the distance from Tim's house to John's house. Do we know the distance from Tim's house to John's house? We don't know. Let's take it as d kilometers. Then what would be distance from John's house to Tim's school? It is given 0.3 times of d. 0.3 into d is distance from John's house to Tim's school. So in this way, if you try to give the details to the question would be simple. So try to simplify the data into small parts. Going forward, Tim's speed from John's house to Tim's school. So what is the talking about? He is talking about Tim's speed from John's house to Tim's school. John's house to Tim's school. This was twice that of Tim's speed from Tim's house to John's house. Let us try to take the Tim's speed from this point to this point as s kilometers per hour. Then what would be average speed from here to here? That is 2 times s. This is what they said. Then by using this context, we should be finding the average speed of Tim from John's house to Tim's school. 2s is our question. Hope you understood the question and this detailing as well. Let us try to go for the basic definition that we discussed just now about average speed. We discussed that average speed is what? It is total distance traveled by the total time taken, right? What is the average speed for the entire journey given? 26 kilometers per hour. Let me write down here. The average speed is given as 26 kilometers per hour. This is equal to, what is the total distance in the journey? Here he traveled d kilometers. Here he traveled 0.d kilometers. Let us write down that. This is d plus 0.3 into d by, what is the total time taken? Time taken is nothing but distance by speed. The distance is d. The speed is s. Here the distance is 0.3 into d and the speed is 2s. Now some of the students are feeling tough in such calculations. Let's try to decode it and make it simple. How do you work out the calculations part? So let us write down here. So 26 is equal to, what is d plus 0.3d? That is 1.3 into d, right? By, shall we take d by s common in both terms? Isn't it? Let us take d by s common, guys. If you take d by s common, here 1 would be remaining. Here 0.3 by 2 would be remaining. 0.3 by 2 is the remaining term, right? So 26 is equal to 1.3 times d by s. If we take LCM, would be 2 plus 0.3, 2.3 by 2. Isn't it? We can cancel d and d. This becomes 26 is equal to 2 into s will inverse. That will be going to numerator 2s into 1.3 by 2.3. How can I write 1.3 by 2.3? By multiplying 10 numerator and denominator, that will be 13 by 23, right? Now 13 goes how many times in 26? It goes 2 times. If we cross multiply, 23 times 2 would be the 2s value, which is what we are looking for. We are looking for Tim's speed from John's house to Tim's school. So the basic concept we discussed here is, how do you use average speed for unequal distances?